Welcome back to Computer Lessons.
We have spent the last few weeks constructing a digital universe, building a machine that captures sound, displays light, and processes information at the speed of thought. But no matter how advanced our processors become, we still live in a physical world dominated by cellulose fibers and pigments. There is a persistent need to drag data out of the screen and onto a sheet of paper, or to shove a physical document back into the digital realm. Today, we are exploring the bridge between these two realities by analyzing the mechanics of printers and scanners. The dream of the paperless office was promised to us in the 1980s, yet global paper consumption has only increased since the computer revolution began. This paradox exists because paper offers a tangible permanence and high-resolution contrast that screens still struggle to replicate perfectly. To understand how we populate these pages, we must look at the two dominant technologies that fight for space on your desk: Inkjet and Laser. They rely on completely different branches of physics. One uses fluid dynamics and pressure, while the other uses electrostatics and heat. Let's begin with the technology most common in homes, the inkjet printer, which is essentially a high-precision squirt gun. The heart of an inkjet printer is the print head, a component that contains thousands of microscopic nozzles narrower than a human hair. There are two main ways to fire these droplets, and the first method utilizes heat in a process called thermal bubble. A tiny resistor heats up instantly, creating a vapor bubble inside the ink chamber which forces a droplet out of the nozzle. The second method, preferred by Epson, uses piezoelectric technology, which is arguably more precise because it doesn't boil the ink. A tiny crystal flexes when electricity hits it, pushing a mechanical diaphragm that ejects the ink without using any heat. Regardless of the firing mechanism, all color printers operate on the CMYK color model using subtractive color mixing. Cyan, magenta, yellow, and key black are layered to subtract brightness from the white paper, creating the full spectrum of colors we see. But here is the illusion. Printers do not actually mix the ink on the paper to create different shades like a painter mixing oils. Instead, they use a technique called dithering, placing tiny dots of pure color next to each other to trick your brain. If you look at a printed photo under a microscope, you will see that a green leaf is actually just a chaotic pattern of yellow and cyan dots. Your human eye is not sharp enough to see the individual dots, so it blends them together into a single color. The precision of these droplets is measured in picoliters, allowing for incredibly high resolutions measured in dpi, or dots per inch. However, this technology has a dark side known as the razor and blades model, where the printer is cheap but the ink is liquid gold. Now, let's move to the heavyweight champion of the corporate world, the laser printer. While inkjets spray liquid, laser printers use a dry plastic powder called toner and a fascinating process called xerography based on static electricity. Inside the machine, a large metal cylinder called the photoreceptor drum is given a massive positive static electrical charge. In the dark, the drum is an insulator, holding the static charge tightly across its entire surface until light touches it. A laser beam scans across the rotating drum, turning on and off to draw the image of your document by discharging the static. This leaves a latent image on the drum, essentially an invisible electrical drawing where the negative space is charged. Next, the drum rotates past the toner hopper, which contains the microscopic plastic dust we call toner. The toner particles are given a positive charge, so they are repelled by the background, but attracted to the neutral areas where the laser struck. Suddenly, the invisible electrical image becomes a visible dust image sitting loosely on the metal cylinder. The printer then passes a sheet of paper under the drum, giving the paper an even stronger negative charge to pull the toner down. At this stage, if you were to sneeze, you would blow the image right off the page because it is just loose dust resting on paper fibers. To make it permanent, the paper travels through the final stage known as the fuser. The fuser unit is essentially a hot iron and a pressure roller that heats the paper to nearly 200 degrees Celsius. It instantly melts the plastic toner particles and fuses them into the fibers, which is why pages come out warm. While printing puts data onto paper, we also need to digitize physical objects using scanners. A scanner is functionally the reverse of a printer, measuring the light reflecting off the paper to create a digital map of the document. The most common technology used in high-quality flatbed scanners is the CCD, or charge-coupled device. Mirrors reflect the image through a lens onto a sensor, providing a high depth of field that keeps even 3D objects relatively sharp. The alternative technology is CIS, or contact image sensor, which is thinner and cheaper but lacks depth. They use LEDs placed right up against the glass, meaning if the paper crinkles even slightly, the image becomes blurry and dark. Just like with audio and monitors, the quality of a scan depends on resolution and bit depth. Scanning at 300 dpi is standard for text, but archiving a rare stamp might require 4,800 dpi, creating massive files showing paper grain. But a raw image of a text document is just a picture. The computer doesn't know it contains words until we use OCR. Optical character recognition software analyzes the patterns of light and dark to recognize shapes as letters and numbers. We have also developed ways to embed digital data directly onto paper for scanners to read instantly, like the QR code. These binary grids contain data and error correction code, allowing machines to read them even if the paper is torn or dirty. But the most revolutionary evolution of printing doesn't use ink at all. It uses molten plastic. 3D printing, or additive manufacturing, builds objects layer by layer on the Z-axis, blurring the line between digital data and physical reality. We also cannot ignore the legacy of the fax machine, the grandfather of modern scanners. It digitized documents into audio screams to send them over telephone lines, a technology that surprisingly still persists in legal and medical industries today. Ultimately, printers and scanners are the intake and exhaust valves of our digital engine. They allow ideas to survive a power outage and allow physical history to be preserved in the cloud, ensuring data is never truly lost. We have covered almost every peripheral, but they all need a way to plug into the computer. In the next video, we will explore the USB revolution and how one simple connector conquered the world.
I want to hear about your setup. Do you still own a printer at home, or do you rely on the office printer to save money? If you found this explanation helpful, please hit the like button and subscribe to Computer Lessons. Don't forget to click the bell icon so you don't miss our next class. Thanks for watching, and keep learning.